Hey guys, we're going to start this lesson with a little warm-up question that's going to help us kind of get ready for the new material. So I'm just asking you, solve the equation. So if you would right now, pause the video and try to solve each of these equations to find the value of x, and try to do so without a calculator. Okay, so whenever you're ready, let's go over answers. So what value of x would make the first equation true? Well, if 2 was raised to the 5th power, then 2 to the 5th power does equal 32. So x would have to be 5. What about the second one? So 1/2 to what power equals 2? Well, these two things were flipped. And in exponent world, if negative exponents occur, that makes things flip around. So if you had a -1 as an exponent here, that would simply make your 1/2 flip to its reciprocal, which makes it 2/1, and that's equal to 2. So x equals -1 is the answer there. Number 3, same thing, it's the flipping thing happening again. So how do I make 3 flip into a 1/3? Well, raise it to the -1 power, and it will be a 1/3. And then the last one, same thing, there's a fraction flipping deal happening here again, except 5 is not the number on the bottom, it's 125. So I do need a negative exponent, but I also need to make 5 into 125, and that can happen if you raise 5 to the 3rd power. So we're going to call this 5 to the -3rd power would make it flip into a fraction and also become 125. Now, what if I gave you this one? 2 to what power equals 29? Well, you would not be able to answer this question without the use of a calculator. I would be able to estimate and say that it's probably 4 point something because I know 5 gives me 32. But there's no way to know exactly what this is equal to without guessing and checking with a calculator. So we're actually going to learn today how we can avoid the guess and check process to find answers to funky exponential equations just like this one. This lesson I'm calling 3.25 because it's kind of like a halfway lesson between 3.2 and 3.3. It's something that should have been presented to you in Algebra 2, but it has not been historically, so I'm going to do this intro lesson, I'm calling it, to logarithms with you today. So a logarithm is just an equivalent way of writing an exponential relationship. So what we can do is we can use a logarithm, which we'll just call log, to define what's happening in an exponential function. So, for example, if 4 squared is equal to 16, obviously 4 squared is equal to 16, then we could rewrite this as log base 4 of 16 and say that that equals 2. So a logarithm will undo an exponential relationship. Okay? The way that you read this is if I see log 232 like this, I would read it as log base 2 of 32. Okay, so here's another thing to go over, and I'm going to keep going over this a lot because this is very, very important. When you evaluate a logarithm, your answer will represent an exponent. Okay, here's what I mean. If I say, what is log base 5 of 625? What I really am asking you is 5 to what power equals 625? That's what I'm really asking you when I present a logarithm to you. So when you give me the answer, when you say, oh, log base 5 of 625 is equal to what, 4? When you give me the answer represents the exponent that creates an exponential function. 5 to what power equals 625? The answer is 4. So the important connection that needs to be made today is that logarithms really are equal to exponents in an exponential function. Let's do some more practice since this is new to you. This says evaluate the logarithms. So when you see a logarithm, I want you to think in your head, 2 to what power equals 32? 2 to what power gives me 32? 2 to the 5th power gives 32, right? So this logarithm, log base 2 of 32, is equal to 5. Let's try another. 3, log base 3 of 27 would be 3 to what power equals 27? That's what you need to be thinking in your head. So what is it? 3 to what power does give you 27? That should be 3, okay? Let's make it a little more challenging now. 4 to what power equals 2? Well, this is kind of weird because how do you go from a 4 to a 2? You can't have a negative exponent because it didn't turn into a fraction. What we would need here is we would need an exponent that would reduce the number, kind of like a square root reduces the number. So think about it this way. The square root of 4 is 2, right? How do you write square roots as exponents? You write it as a fractional exponent. So 4 to the 1/2 power means square root of 4, and square root of 4 is 2. So 4 to the 1/2 power would be equal to 2. Okay, let's try the next. Log base 10 of 1/100 means 10 to what power equals 1 over 100. So here we're going to need a negative exponent, but we also are going to need something more to make it into a 100. So 10 to the negative 2 would make it go to 100, but also put it into a fraction because of the negative. 2 more. Log base 3 of 1. So 3 to what power equals 1? That's what you're thinking in your head. 3 to what power equals 1? Well, anything to the power of something equals 1, right? Anything to the power of 0 is equal to 1. Last one. Log base 2 of 2 means 2 to what power equals 2? Well, 2 to the 1st power would work, wouldn't it? Okay, see why I wanted you to practice exponent rules so much last week? That's because I knew this was coming, okay? Couple of note-taking things. You don't need to write all this down, but make sure that you understand what I'm saying here. This is about your calculator. So some of you have probably noticed that your calculator has a button, a log button. So on these little TI calculators, there's a log button right here under the second, right here. In a graphing calculator, there's also a log button, but I think you have to hit math to get to that, that option. Maybe it is on the keypad too, I'm not sure. Here's the catch though. The log button on your calculator most of the time does not have the option to change the base, because the log button on your calculator is already programmed to be log base 10, okay? And a lot of logarithms are not base 10, but on your calculator, it's set that way because things like the metric system and a lot of things we deal with in everyday life are based on a base 10 computation system. So that's why it's programmed into your calculator, but you don't have the option to change it to a different base. So just be aware that that log button is not going to give you log base 2 or log base 5. It's only for base 10. Log base 10, by the way, is called the common log. Again, the reason for that is our numerical system. A lot of things that we deal with in everyday life are based on tens. So it makes sense that we would want something to have a base 10 to represent that. Okay, so this is a calculator problem, and you can actually do logarithms on your phone. If you, I know if you have an iPhone, if you turn your phone sideways, you will find a log button, and it actually does say, it's right over here, log base 10. So you can use that to help you here, but this is just simple calculation stuff to do on your calculator. On your calculator, though, understand you would just press the log button and then put 10. So it'd be log 10 in your calculator. So you would not do anything with the base here. You're just putting log and then the number. This one should equal 1. For the next one, you would do 2 times log of 2.5. That's how it would be in your calculator screen. That should equal 0.796. What happens down here? If I type in log of -2, what happens? You should be getting something that's like either error or undefined. I can't remember the way it's written on your calculator, but it doesn't work. Let's think about why for a second. Let's write the logarithm as an exponent, like I told you how you should be thinking through it in your head, okay? 10 to what power equals -2? That's the question I asked you. When I asked you to do log base 10 of -2, I was asking you to say 10 to what power equals -2? Is it possible to raise a whole number like 10 to a power and get a negative answer? We could get a smaller number if it was like a square root situation. We could get a fraction if it was a negative exponent, but there's no way to get a negative answer out of it. And actually that's going to be true for all cases. You can't raise a number to a power and get a negative answer unless that number was negative to begin with. Okay, here are a few basic logarithm properties, and I am going to ask you to have these written down. I'm also going to have you write a couple of notes to explain why these are properties, okay? If you understand the why, it will make the memorizing part of it way easier, okay? So this says log of any base of 1 will always equal 0. To explain this, let's rewrite it as an exponent. So we say b to the power of 0, that's how this would work, is equal to 1. Does this make sense to you? Anything, no matter what b is, if I raise it to the 0 power, I always get 1, right? That makes sense, and if you turn it into a logarithm, then the logarithm should also make sense to you. Let's try the next one. Log base b of b equals 1. So it doesn't matter what b is, but if these two numbers are the same, the answer will be 1. Why is that? So let's rewrite this again as an exponential. So we're going to take the base, b to the power of 1 equals b. Does this make sense to you? Does b to the power of 1 equal b? Sure does. So that's the reason why this logarithm is a property. Third property, this is kind of a weird one. Remember, b has to be a matching number. So this says log base b of b to the x equals x. So whatever this number is what it would equal. That's what the property is suggesting. Let's rewrite it as an exponential. So you take the base, which is b. The outside thing is the exponent, or whatever it equals is the exponent. And that's supposed to be the inside value. So b to the x equals b to the x is what we end up with when we rewrite it as an exponential. And when you write it that way, that makes sense because obviously these two things are the same, aren't they? Okay. Property number 4, this is real funky looking, but it says b raised to the power of log base b of x equals x. Basically, I'm not going to rewrite this one as an exponential. I'm going to just tell you what's happening here. What's happening is you have an exponential and a logarithm canceling each other out because exponentials and logarithms are actually inverses of each other. They undo one another. So this b and this log base b cancel each other out. So whatever is left here is what your answer would be. Let me show you a more concrete example so you can see what that could look like. That could look like, oh my gosh, let me see. Maybe, I don't know, 4 to the log base 4 of, I don't know, not 3. Yeah, 3. Sure, 3. So if I said, what is this equal? Well, you should recognize that the exponential and the log base 4, since it's the 4th base and this is a base of 4, then those cancel each other out and leave you with just this number here, which is 3. Okay, last one. If log base b of x is equal to log base b of y, then x equals y. Okay, this just means that if I have log base 4 of x and I have log base 4 of y, and I've put them into an equation where they have to be equal, if this is a log base 4 and this is also a log base 4, then the only way to make this equation equal is if the x was equal to the y. Okay, so that one's just an equality statement more than anything. Okay, so what we're going to do is use a couple of these properties to help us solve equations, okay? Just a couple of them. So look back at your list of properties from the last slide and tell me which property you think we could apply to equation A, properties 1, 2, 3, 4, or 5. I think this one looks most like property number 5. Okay, to me, I see log base 2 are identical on both sides. I have an equal sign in between, and we're just being asked, how do I make these two things equal to each other? So if you see log base 2 and log base 2, then the only way to make this equation equal is if x was equal to 3. So you've just solved it. X is equal to 3. What property are we thinking for B? Which property does this match or like appear to look like, I guess? This one looks to me, let me go back. Looks to me like number 3, the way that number 3 is set up. So let's see if we can make it look like number 3. So log base 4 of 4, oh, maybe not number 3, hold on. It's number 2. Log base b of b is log base 4 of 4. So this is property number 2. Log base b of b, if we see a base that matches the number on the inside, then we could easily just say, based on properties, I know that this has to be 1. Your second option, though, for this one is you could just think about what this means. Remember, this would mean 4 to what power equals 4, and obviously that would have to be a 1. Okay, I want to show you a couple of things just to reiterate what the basic logarithms can do. We're actually going to skip these. Let's go to the evaluate questions. These are going to help you with your assignment. So evaluate each expression. Log base 3 of 1 over 243. So you need to be thinking 3 to what power equals 1 over 243. I have to make it a fraction, so I would need a negative exponent. And then 3 to what power equals 243? I believe that's 5. So negative 5 for that one. Number 8, 2 to what power? That's supposed to be a question mark. Equals 1/8. Again, I need a negative to make it a fraction. And then I think 3, 2 to the third would be 8. So negative third would make it 1/8. Let me go back now and address those first few questions that I skipped. I think you may have to do this on your assignment, so let me just show you. Rewrite each equation in exponential form. So when I say what's log base 25 of 5, I've been telling you that that means 25 to what power equals 5, right? Well, when you have the answer over here, you no longer have a question, you have your answer. 25 to the 1/2 power is equal to 5. So that's how you rewrite a logarithmic statement in exponential form. You just write it like an exponent. So this one would be 14 to what power equals 1 over 196. But since we know what it's equal to, then that means we know the power that does make it equal 1 over 196. So this would be your exponential form. Rewrite each equation in logarithmic form. This is fun. Okay, so if 25 to the 1/2 power is equal to 5 is the same as log base 25 of 5, then we're going to write it as a logarithm, kind of like doing this, but in reverse. Okay, so I'm going to make the connection for you. The base, the thing that holds your exponent, becomes the base of your logarithm. See that? The base of my exponent here is 15, so the base of my logarithm will be 15. Okay? The exponent is the answer, right? So 1/2 was the exponent and 1/2 was the answer, so I need my exponent to be my answer. And then the number on the outside becomes the number that goes inside the logarithm. So 225 goes in here like that. That's how you write it as a logarithm. This one's a bit harder because there's different letters instead of numbers, but same idea. So the thing holding the exponent is the base of the logarithm. The number on, or I'm sorry, the exponent goes on the outside here. And then the number on the outside goes to the inside. Okay, I think that's all I'm going to do with you today in this lesson. So go ahead and get started on your assignment for this and just let me know what you need.